All right, if you're looking to kickstart your DevOps career, you have come to the perfect place. Over the next few minutes, we're going to pull back the curtain on one of the most critical tools out there today, Docker. Think of this as your first mentorship session. Let's get right into it.
Oh man, we have all been there, right? You spend days, maybe weeks, writing some amazing code. It runs like a dream on your laptop, but the second you hand it off to a teammate or try to push it to a server, bam, it just breaks. It's not just annoying, it's probably the #1 cause of headaches in software development, creating chaos and delaying everything. And this exact problem is why containers were invented. The whole idea behind containerization is actually pretty simple, but it's totally revolutionary. You create one single, neat package that holds your application and everything it needs to run. All the libraries, the right versions, the configs, the whole shebang. And the guarantee? It will run the exact same way every single time, no matter whose machine it's on.
Now, to really get why containers are such a game changer, it helps to see how we got here. In the old days, we had bare metal servers. That meant one server, one application. Super simple, but wildly inefficient. Then along came virtual machines, or VMs. These were a big step up. They let us slice up a physical server to run multiple apps. But each VM needed its own entire operating system, which made them super heavy and slow to start up. Containers, they're the next evolution. They cleverly share the main computer's operating system, making them incredibly light, lightning fast to start, and way, way more efficient.
So, what is a container, really? The best way to think about it is like a real-world shipping container. Before those existed, moving goods was a total mess. You had barrels and crates and sacks of all shapes and sizes. The shipping container standardized everything. Suddenly, it didn't matter if you were shipping bananas or car parts. It could be moved by any crane, any ship, any truck. A software container does the exact same thing for your code. It's that standard box that lets you build it, ship it, and run it absolutely anywhere.
Okay, so understanding the why is one thing, but putting it into practice is what really matters. The entire Docker workflow, the whole process, can be boiled down to just 3 simple words. Build, ship, run. That's the mantra. Let's break down what each of those means.
This is the fundamental loop you are going to live in as a developer using Docker. It's a rhythm. First, you build. You package up your application into a template called an image. Then you ship. You push that image to a central library called a registry. And finally, you run. You or anyone else can pull that image down and bring it to life as a running container.
So that build phase, it all starts with a file called a Docker file. It's literally just a plain text file, but don't let that fool you, it's incredibly powerful. This is the step-by-step recipe that tells Docker exactly how to construct your application's environment. It says, hey, start with this operating system, then copy my code in, then install these specific things, and finally, run this command to start everything up. It's the blueprint.
Now here's a really cool and crucial concept. Every single instruction you write in that Docker file creates a read-only layer. The best way to picture it is like you're stacking transparent sheets of plastic. The base OS is the bottom sheet. Installing a library adds another sheet on top of that. Copying your code adds another. This is brilliant because if you only change your code at the very top, Docker is smart enough to only rebuild that one tiny layer, making your builds incredibly fast. This is a total game changer for automated pipelines.
Okay, once your image is built, you need to ship it somewhere, right? That's where a container registry comes in. You can think of it as a central warehouse or library for all your Docker images. The most famous one is Docker Hub, which is basically the GitHub for container images. It's packed with millions of pre-built images that you can use as a starting point for your own projects.
And this really shows you how big the ecosystem is. While Docker Hub is the go-to public registry, all the major cloud players, Amazon, Google, Microsoft, even GitHub, they all have their own powerful private registries. As you get into a professional role, you'll almost certainly be using one of these to securely store your company's private code, right there next to all your other cloud stuff.
And finally, we get to the run phase. This is where the magic really happens, and honestly, it's often as simple as one command, Docker run. When you type that, Docker first checks if it has the image on your machine. If not, it automatically goes out to a registry, pulls it down, and then, poof, it creates a live, running instance of that image. That's your container. That one command brings your entire application to life.
All right, quick pop quiz to make sure you're with me. What's the name of that file that acts as the recipe or the blueprint for building a Docker image? Is it A, B, or C? If you said B, Docker file, you are absolutely right. That's the heart of the whole build process.
So far, we've mostly talked about making sure your app runs the same everywhere. But here's the secret weapon. Docker is also going to completely transform how you write code every single day. It's going to make your life so much easier.
This is where you'll really feel the power. You can set up hot reloading, so when you hit save on your code, the running application inside the container instantly updates. No more restarting. You can attach a debugger directly inside the container to see exactly what's going on in that perfect, isolated environment. You can spin up a fresh, clean database for every single test run, and you can build CI pipelines that are a perfect clone of production. It just removes so much friction from your workflow.
Of course, things will go wrong. That's just a fact of life in development. So when your image build fails, don't panic. Just read the output carefully, line by line. It'll tell you which command failed. If your container just won't start, the Docker logs command is your absolute best friend. It will show you exactly what error the application is throwing. And if you can't connect to your app, 9 times out of 10, you just need to double-check your port mapping. This little table covers the big 3 issues you'll hit at first.
Okay, so you're learning the commands, you're figuring out how to fix things when they break, but what does this all mean for your career? Let's connect the dots from these tech skills to your actual professional growth. Check out this number. Over 90%, that is a huge majority, of modern software companies are using containers in production. This isn't some niche optional skill anymore. It is a fundamental, core requirement. Knowing Docker isn't just a nice-to-have on your resume. It is a key that directly unlocks the door to roles in DevOps, back-end engineering, you name it. And here is your path forward. It's a pretty clear road. Step 1 is to master Docker, which is exactly what you're doing right now. The next logical step is to learn an orchestrator like Kubernetes, which is the tool used to manage thousands of containers at scale. Once you've got those 2 down, you are on a direct path to a high-impact and very high-demand DevOps role. Now, when you get into those job interviews, let me give you a heads up. They're going to ask you questions like, how do you make your images smaller and more secure? Or, how do you handle saving data with volumes? They'll also want you to explain how containers talk to each other over the network. These are the topics you'll want to dig into as you go from a beginner to an intermediate user. And look, your journey doesn't end here. The official Docker documentation should be your go-to source for everything. Communities on places like Discord or finding local meetups are amazing for asking questions and meeting people. And honestly, the best way to get real-world experience is to contribute to an open-source project. Use these resources, they're there to help you grow. So, if there's one thing you take away from all this, let it be this. Mastering containers isn't just about learning a new command. It's about learning the fundamental blueprint for how almost all modern software is built, shipped, and run across the entire world. Keep building, keep asking questions, and you are going to be well on your way.